An inequality is a mathematical sentence containing one of the following symbols: less than, greater than, less than or equal to, or greater than or equal to. When you're solving inequalities, you're searching for a solution to the inequality. And a solution of an inequality is a value for the variable that makes the inequality true. So let's look at some values that could make an inequality true. Let's circle the numbers that are solutions for the inequality x is greater than -3. We would know that 4 is greater than -3, and 0 is greater than -3. -5 is not, and -3 is not greater than -3. -2.9 is greater than -3 because it would be right of -3 on the number line. So you can see that more than one number is often a solution to an inequality. So, when we're solving an inequality, we use the same steps we used for solving equations. There's one change. When you multiply or divide both sides of an inequality by a negative number, the direction of the inequality symbol has to be reversed. So just to review here, our addition property says that if you have an equation, you can add some number to both sides and the equation stays the same. That's also true for inequalities. But with inequalities, what we see is that if you multiply both sides by a number that's positive, let's say c is greater than 0, then everything remains the same as an equation. But if you multiply both sides by a negative number, you can see what's happening to our sign. When you multiply both sides, the sign flips. So let's see a few examples of how to solve an inequality. Now, when we solve inequalities, we usually like to graph as well. Since there are multiple solutions, or often infinite solutions to an inequality, then we need to show our solutions on a graph to demonstrate all the different solutions that are possible for the inequality. So let's see our first inequality. X plus 10 is less than -6. We want to isolate our variable, just like we would with any other equation, except now we're going with inequality. So we subtract 10 from both sides. So x is greater than -16. Now, we up here say that we need to write in set builder notation. There's special notation that we use for how to write the solutions to inequalities. And the notation that we use is this. We use our braces, just like we would with our solutions to equations, and we say that our solution is x such that, and that's what that line means, such that x is greater than -16. So this is our solution, and this is the rule. Our solution is any value of x as long as x is greater than -16. So let's go ahead and use our number line to graph this inequality now. We'll put -16 in the middle, -17, -18, -15, and -14. And if we remember from before, since this is greater than, we want to use an open circle, and we are going to shape everything to the right, since it's greater than. Let's go to example 2 now. Example 2, we again want to isolate the variable. This time we'll add 5 to both sides. And remember, when we're adding or subtracting, we don't need to flip the sign. So a is less than or equal to 1. Always read your inequalities from the variable first. A is less than or equal to -1. Now let's write our solution in set builder notation. Our solution is a as long as a is less than or equal to 1. And now we can graph it. Make our number line. And now we want to put a closed circle at 1 since it's less than or equal to. All right? And then we shade all the values less than 1. So all of our solutions are left of 1 on the number line. 2 more examples. Number 3, we could approach this 2 ways. We could try and clear the fraction, but what I'll do is I'll just multiply by the reciprocal to isolate the variable. 3 over 2. And so we'll remember that this is 8 over 1. So you get n is less than 1 and 4. -12 over 1, which is -12. Now we don't need to flip the sign since we multiplied both sides by a positive 3/2. Let's write our solution in set builder notation. n as our solution, as long as n is less than negative 12. And again, let's make our number line. So we'll do an open circle since there's no or equal to part to our inequality, and we shade all the values less than negative 12. So negative 13, negative 14, and all the decimals in between. And our last one. Here we have negative 5y is less than or equal to 40. In order to isolate our y variable, we need to divide both sides by negative 5. But here's where our special rule for inequality comes into place. If you multiply or divide both sides of an inequality by a negative number, like we did here, you end up needing to flip the sign. So instead of y being less than, y is now greater than or equal to negative 8. You can see the direction of my sign flipped. So my solution in set builder notation is y is my solution as long as y is greater than or equal to negative 8. And let's graph that last one. Put negative 8 in the middle. And then we go two values smaller and then two values greater. And now we do a closed circle since it's greater than or equal to. And then we shade all the values greater than negative 8, which would be all the values to the right.